Welcome back, Pre-P Physics students. In this video, we're going to be discussing advanced vectors. Here are our objectives. First, we're going to review basics, things we've already covered. Then we're going to learn how to add vectors graphically. Next, we're going to review basic trigonometry and how to use things like the sine, cosine, and tangent. Then we're going to learn how to find x and y components of vectors using these trig functions. Then we're going to learn how to find the magnitude of a vector given its components. We're going to learn how to add vectors algebraically instead of graphically. And then finally, we're going to learn how to figure out an angle that a vector points in once we know its components. Let's get started. Let's go back over vector basics for a moment. You'll recall that vectors are mathematical objects that have both a magnitude and a direction. This is in contrast to scalars, which were things like your height that had no direction whatsoever. We've already studied a lot of vectors in this class. Displacement, velocity, acceleration, all of which are vectors. Remember, they all had a direction. And you'll also recall from the very first video, or one of the first videos we did, that I showed you that you can represent vectors graphically using arrows. And it's very important that you use arrows and not just lines. A line doesn't have a direction, an arrow does. If you draw an arrow to represent a vector, like the two I've shown here on the bottom, the direction the arrow points is the direction of the vector. Meanwhile, the length of the arrow is proportional to the magnitude of the vector. And that's why this 20 meter per second velocity, you'll notice that the vector arrow representing it is half as long as the one that's 40 meters per second. Last time you saw how to represent vectors graphically, but we didn't get into how to put them together. Well, now we're going to learn how to add vectors graphically using these arrows. Say we've got different vectors like A and B that you see here on the left. We can add these vectors together by placing them tip to tail. Now, what do I mean by tip and tail? The tip of the vector is the arrowhead. The tail is the other end. Okay, so this would be the tip. This would be the tail. And anytime I take vectors and I attach the tail of one of them to the tip of another, I've essentially added them together. Now to see what I get, what the result of the addition, which we call the resultant vector, it's the sum of the two vectors. To see how to find that, I essentially have to draw a shortcut from the first vector where it began, its tail, to the tip of the last one. It's just a shortcut from beginning to end. And if you look here on the right, I have this drawn out for you. A plus B equals C. And you can tell I've added A and B, tip to tail, and then I've drawn the resultant, which is C, which is the equivalent of A and B, added together. Here are some basic things you might want to know about vector addition. The first thing is that just like when you're adding numbers, the order does not matter. A plus B is the same as B plus A. Here's a quick example. I've got these two vectors here on the left, A and B, and you notice A is the one that's black, B is the one that's blue. I'm going to add A and B together. Let's say I take A here, and then I attach B tip to tail. There's my resultant. That's A plus B. Now, I can add them in the opposite order. Let me start with B this time. There's B. Now, I'm going to add A, just like that, tip to tail. And if I were to draw my resultant, it would look just like that. It's exactly the same. Second thing you want to know is that to add together more than two vectors, you just continue to add them tip to tail. So say, for example, that I had this vector, and then I had a second vector. We'll call this one A. Maybe I had a second vector B that may be pointed like this. If I connected it tip to tail to A, so far I've added two of them together. And let's say I had a third one, C, and let's say it went back like this. And I had these three vectors, and I wanted to add them together, just as I've done here, tip to tail. The resultant vector, what I get when I put them all together, would be that vector, the shortcut from A to B to C. All right, here are some additional things you're going to want to know. Sometimes you're going to need to be able to find the opposite or the negative of a vector. And to do this, all you have to do is draw a second vector that has the same length or magnitude as the first vector, but points in exactly the opposite direction. So as you see here, if this vector is A, the negative A would be this vector. It's just as long, but points in exactly the opposite direction as A. Now, we're going to use this to subtract vectors. The key idea for subtraction is to recognize that subtraction is the same thing mathematically as adding the opposite or adding the negative. So, for example, just like in math class, a minus b is the same thing as a plus negative b. So if you have a situation like this where you have to subtract a vector from another one, all you have to do is reverse the vector that is the negative. So for example, in this case, I have a minus b, so I'm going to have to reverse it to get a negative b. And I've done that right here. There's my negative b. And then my subtraction problem has just become an addition problem. I'm going to add a and negative b. So let me grab my a and move it over here. There's a. Let me grab my negative b, place it there, and now I can draw my resultant. That is a plus negative b, or a minus b. One more thing that you might want to note that may seem obvious to some of you, if I wanted to find, say, the vector 2a, I just draw a vector that is twice as long as a and points the same way. So if this was my a vector right here, then 2a would point the same way but be twice as long. Just like that. Now typically when we work with vectors, we work with what we refer to as components. And components are pieces or individual vectors that when I put them together, when I add all these component pieces, I get back the whole vector. Most of the time, we're going to deal with x and y components. And x and y components mean the pieces of the whole vector that point only left-right in the case of x, or up-down in the case of y. If you look down here, you'll see how this works. So I have this vector on the left that is a. And you'll notice that it points somewhat to the right and somewhat up. Somewhat in the x and somewhat in the y. If I wanted to break it into components, I would need to do what you see here on the right. The part that goes just up in the y direction, I've labeled AY. That is the y component of A. We usually use a little y or x, a little subscript to indicate the component. Here I've got the part that goes only in the x direction, and I've labeled it AX. That's the x component. And what I want you to notice is if I take this x component and I add it tip to tail with the y component, what I get back is A. That means A is equivalent to AX plus AY. That's a very important idea. It's exactly the same thing. Next, we're going to practice looking at components of various vectors and determining if the x and y components are positive or negative. That's right, they could be either one. To do this, I've got this simulation provided by PhET. Here, a vector has been drawn, and if I were to label its x and y components, first to get the x, I'd have to go as far over in the x direction as I could, about that far, and then as far up in the y direction as I could. And you notice that when these two things come together, I've formed the whole vector. This would be, if this was vector A, that would be the x component and the y component. Now what's great is, the simulator will actually draw them in for me. And there they are. You notice I've drawn them correctly. There are my two components. Now, you might remember from when we did one-dimensional kinematics before this that we had a sign convention. We said that to the right was positive. Let me do that in black. To the right was positive. To the left was negative. Well, this is for x, left, right. For y, up was positive and down was negative. Well, we're going to have to be very careful to follow that sign convention when we look at components. For example, my AY component here points up. Therefore, it's a positive y component. The x component points to the right. Therefore, it's a positive x component. Let's try a different vector. In fact, we'll try a few different vectors, and let's see if we can figure out if the x and y components are positive or negative. All right, let's create a new vector. I'm just going to take this one and rotate it and change the length so it's now a different vector. There's my vector. There are its components. In the x direction, it has this component, and in the y direction, it has this component. Is the x component positive or negative? Well, it points to the right, so it's a positive x component. What about the y component? Well, it goes down, so it's a negative y component. Let's try another one. Let me grab a new vector. Let's say this vector points down like so. You'll notice that this is the x component, and it points to the left. This is the y component. It points down. Since the x component points left, it must be negative. Since the y component points down, it must also be negative. Keep this in mind as we move forward and start using actual numbers for the components. Alright, it's time for a short break and an opportunity for you guys to check your understanding by doing the prep check questions on what we've done thus far. Once you've completed those questions, which immediately follow this video, inside your assignment, you can proceed to the next video where we will continue our study.